Vanakkam one and all. We will discuss problem number 18 of exercise 5.1. Here, for what values of lambda is the function defined by f of x? The f of x will be this expression whenever the values of x is less than or equal to 0 and the values of x are greater than 0, the function will be 4x plus 1. They are asking the values of lambda for which the function is continuous at 0, and they are asking us to find the continuity or discuss the continuity of the function at x equal to 1. Now, to say a function is continuous at 0, the left hand limit, right hand limit and the functional value should be equal. I will write it now. Limit of the function as x tends to 0 from left hand neighborhood equals to the limit of the function as x tends to 0 from right hand neighborhood equals to the functional value. So in this case we can say the function is continuous at 0. So we will first we will see the domain of the function. 0, plus infinity and minus infinity, and whenever the values of x less than or equal to 0, the function is lambda into x square minus 2x, and here whenever the values of x greater than 0, function will be 4x plus 1. Now we will discuss the continuity and at 0, and we will assume the continuity at we'll discuss the continuity at 0. Now to say the function is continuous at 0, we have to know the functional value. So the value of the function at x equal to 0, lambda into x square minus 2x, which is equal to lambda into 0 square minus 2 into 0, which is nothing but lambda into 0, that is 0. So the functional value at x equal to 0 is 0. Now let's calculate the limit of the function as x tends to 0 from left hand neighborhood. In the left hand neighborhood, the function has been defined like this: lambda into x square minus 2x. After substituting x as 0 over the expression, we will get again 0. Now we will consider about the right hand limit. Limit x tends to 0. So limit of the function 4x plus 1 as x tends to 0 from right hand neighborhood is equal to 4 into 0 plus 1, which is 1. So here the left hand limit exists and right hand limit exists, but they are not equal. So we can say the function is discontinuous. We are not able to get a limit. Therefore the function is discontinuous at 0. So whatever the value that lambda takes, that not influence the continuity of the function at 0. So lambda value is not influencing, it's not affecting the continuity. It's not affecting the continuity, or it's not influencing the continuity. So for any value of lambda, for any value of lambda, f of x is discontinuous at x equal to 0. Okay. Now we will discuss the continuity at x equal to 1. At x equal to 1. So when the value of x equal to 1, the function will be 4x plus 1. So f of x will be 4x plus 1. We will know the functional value. F of 1 will be 4 into 1 plus 1, which is 5. And we will calculate the limit x tends to 1 f of x. So limit of the function as x tends to 1, which is 4 into 1 plus 1, again 5. Here this limit of the function as x tends to 1 is equal to the functional value at x equal to 1. So we can say the function is continuous. It implies the function is continuous. Here again the lambda is not affecting the continuity. So for any value of lambda, the function is continuous. For any value of lambda, the function is continuous.